So in the SI system, there are prefixes that have different meanings. So in the SI system, there are different prefixes that have different meanings that indicate different quantities of the unit being described. Those prefixes are kilo, hecto, deca, deci, centi, and milli. And you put these together with the base units we've described, like meters, kilometers, hectometers, decameters. Or we could use the units for mass. We could have kilograms, hectograms, decagrams. Or we could use other units like liters. We could have centiliters, deciliters, centiliters, milliliters. These units can be used in conjunction with any SI unit, but these prefixes always have the same meaning. The kilo prefix always means that you have 1,000 of something. The hecto prefix always means that you have 100 of the unit. Deca means that you have 10 of the unit. If you have no prefix, then you just have the unit itself. You just have one of them. Deci means you have 0.1 of the main unit. Centi means you have 0.01 of the unit. And milli means you have 0.001 of the base unit. You do need to have these memorized. And one way that students use to help them memorize this order is the mnemonic device, King Henry died while drinking chocolate milk. And whether you use the word while there or not, there's nothing that begins with a W, but it might help you remember this order. King for kilo, Henry for hecto, died for deca, drinking for deci, chocolate for centi, milk for milli. The ones to watch out for, of course, are the deca and the deci, because they both begin with a D. So that requires a little bit more attention to help you remember. Now, some of you may be able to do these conversions from grams to milligrams just moving the decimal place. That may be something that you should have learned in middle school. So 5.712 grams to milligrams, hopefully you know that a milligram is 0.001 grams. 1 milligram is 0.001 grams. And so you know that if I want to express this in milligrams, I have to move the decimal point 3 times, and I have 5,712 milligrams. However, it is important to also be able to get this answer using dimensional analysis. It's important to be able to do it because sometimes you need to switch from one unit to another in the middle of a dimensional analysis problem, and you don't want to have to stop and get your answer and move the decimal point and then go back to dimensional analysis. It's easier to do it all in one step. So if you know how to move the decimal point, that's great. You can check your answers as you go along. If you don't know how to do it, then you're just relying on the dimensional analysis to help you do it. So if I have 5.712 grams as my known, the conversion factor I want to use is 0.001 grams is the same as 1 milligram. When I do the math, I should get, remember, my units cancel, my grams cancel with grams, I'm left with milligrams, and I have 5,712 milligrams as my answer. Maybe this is not the conversion factor you have memorized. You might have a different conversion factor memorized. You might know that there are 1,000 milligrams in 1 gram. That conversion factor works too. We can do 5.712 grams, and our conversion factor can be 1 gram is the same as 1,000 milligrams. This also works. We still get 5,712 milligrams. So there are a couple of different ways you can memorize the conversion factors. but you do need to know these conversion factors. There are more conversion factors. You can go beyond kilo. You can have megameters, or you can get smaller. You can have micrometers, but these are the main ones that you need to have memorized. Let's do another example. How many centimeters are in 16.45 meters? You might know that there are 100 centimeters in 1 meter, or you might know that that 1 centimeter is the same as 0.01 meters. Both of these conversion factors will work in the problem. It doesn't matter which one you use. I'm going to go ahead and do 16.45 meters. I want to know how many centimeters that is. So I have to have meters down below and centimeters up top so that those meters will cancel out. But what number goes in here? I will go ahead and write the 100 centimeters is the same as 1 meter. And I get as my answer 1,645 centimeters. 570 liters equals how many kiloliters? Kilo means 1,000. So 1 kiloliter is the same as 1,000 liters. Or if you reverse that, you might know that 1 liter is the same as 0.001 kiloliters. Both of these conversion factors work. It doesn't matter which one you use. So whichever set of conversions is easier for you to memorize, go with it. I have 570 liters, and I need a conversion factor to get rid of liters and bring in kiloliters. So I'm going to go ahead and write that 1 kiloliter is the same as 1,000 liters. Okay, so when I do the math, I get 0.57. Now, I might want to write 0.570 as my answer, but I only have 2 sig figs in my known. Therefore, I should only have 2 sig figs in my final answer. So the correct final answer is 0.57 kiloliters. I forgot to cross out my units. My liters cancel out, and I only have kiloliters left, which is what I want to have in my answer. Okay, here's a multi-step, converting from kilometers or kilometers to centimeters. You might not know how to convert from kilometers to centimeters. You do know, however, or you should know, that there are 1,000 meters is the same as 1 kilometer, and that 1 meter is the same as 100 centimeters. So I don't know how to go from kilometers to centimeters in one step, but I can go kilometers to meters and then go from meters to centimeters. Okay, so that's what I'm going to do here. I'm going to do a multi-step problem. I'm going to start with my known 0.0026 kilometers. My first step is to switch from kilometers to meters. Kilometers, 1 kilometer is the same as 1,000 meters. And my second step is going to be to get rid of the meters this time and bring in centimeters for my final answer. And according to my conversion factor, 1 meter is the same as 100 centimeters. So when I do my math, I get 260 centimeters. 0.0026 times 1,000 times 100 divided by 1 divided by 1 gives you 260 centimeters. And that has 2 sig figs, just like I should have according to my starting value. So even if you know how to move the decimal point to convert from one metric prefix to another metric prefix, it's important to be able to set them up as dimensional analysis problems. If you already know the answer, that's great. You know what the answer should be at the end, and that might help you figure out the correct conversion factor. Hopefully this helped.